Okay, so we have this right here. Okay, let me plug this in because the microphone is necessary for what we do. What does Mr. Bird say? Yeah, I always hear that every day. Yeah, boy, or something like that. I don't know, I hear that sound all the time. We can write an equation like this in matrices. Okay, I'm going to show you how to use your calculator today to solve those systems of equations. Not today, actually tomorrow. But I'm going to show you how to use your machine to do so. So like I've been saying, it is important to have a machine. On your test, we will actually have a sheet full of just calculator stuff, and half of your test will be without a calculator stuff. You'll have two different parts of the test. Okay? So I am testing you on knowing some things, but you are going to use your calculator, and yes, you will need to know how to use your calculator. You're going to go through hell. So make sure you have it. Make sure it comes with you. There's still about 50 to 100 still rentables. Okay, if you don't have one, get one. There shouldn't have been an excuse so far anyway. All right, here we go. So what I'm going to do is I'm going to first write my coefficient matrix. Looks like this. Notice it's just the coefficients of my x's and the coefficients of my y's. Does that make sense to everybody? That's called your coefficient matrix. Then I'm going to have my variable matrix. And then I'm going to have my solution or answer matrix, I guess you could call it. Yeah, haircut! That's very lovely. Okay, once again, guys, a matrix is just a way to organize things. We're going to organize a system of equations without variables now. I'm just going to play around with this a lot of the times today. I'm just going to play, not here around today, but when we start solving, they're going to look just like this. I don't have variables with them, but I just remove the variables and start playing with numbers. Makes it very simple. Okay. Anyway, we could actually solve this. This is timesing right here. How do we get rid of timesing? Division. What's another way to get rid of division? We don't do division with matrices, so what would I do? How would I get rid of like a 3x equals 9 without dividing? Instead of dividing by 3, I'd multiply by 1/3, which is called a multiplicative inverse, correct? So what I would do is I'd multiply, if I called this matrix A, I'd times this matrix inverse to both sides. That's how I would do it. Now I'm going to show you how to do that later, but that's how easy it is. And then I can just say, oh, xy equals this matrix times that. Whatever that is. We haven't got there yet, and that's not the goal. I'm just trying to show you an example of why we use matrices. It helps us organize data a little bit nicer. Okay? But in order for us to do things, we have to tell its order. Its order is its dimensions. Okay? So order, when I ask what is the order of something, you're asking about the dimensions. And with the dimensions of a matrix, we always go rows by columns. Okay? So can somebody tell me the order of this matrix right here, matrix A, the coefficient matrix? How many rows are there? 2. How many columns are there? 2. It's a 2 by 2. Now, guys, I never had a problem with that. I always had to struggle. Which ones are rows? Which ones are columns? Because technically, in this classroom, don't we call what you guys are sitting in rows? So that's why I always got confused. Because you're being vertical. Technically, you guys are in what? You're actually in columns. And the way somebody explained it to me is you put books on a row or on a shelf, right? So you lay them sideways. Okay, columns hold things up. The Colosseum, column. That's how I had to think about it. So if you struggle with rows and columns hold things up, rows you set a book on, right? So how many rows and how many columns do I have here? 1 column and 2 rows, so this would be a 2 by 1, right? Does everybody understand that? What's the order of my solution? 2 by 1. Okay? Now what if I wanted to say what number 1 is? in that matrix over there? Well, each element, one is called an element, has its very own spot. Okay? That is in the first row and the second column. So we call this element A1, 2. 1 is considered element A1, 2. So let's talk about Taylor right here. In our classroom, notice we have 1, 2, 3, 4, 5, 6, 7 rows. 1, 2, 3, 4, 5, 6 columns, don't we? So we have, if this was a matrix, we have a 7 by 6 classroom. Does that make sense? Taylor's specific seat is specific, right? She is in row 2, column 4. So she would be in our classroom 2, 4. You would be in 3, 3. You have a distinct spot. Parker's in 1, 1. Okay, Cody back in the back is in 7, 1. Distinct spots, right? Does that make sense? So next time when we switch your seating chart around, I'm like, all right, you go to A2. 2, 1. Or whatever. I'll shut up. That wasn't as funny as I thought it was. Battleship. And it's like a grid on a map, or battleship, right? It's a specific location. Exactly. Longitude, latitude, some GPS and some geocaching. Huh? I love me some GPS. What? Every chess we say that. Knights to E4. Rabbit. Okay. So I'm going to write these matrices down. I'm going to call this matrix A. 3, 2, 1, -1, -5, and 3. Write those down quickly. What A plus B is, and that's a plus. And what B plus A are. Okay, quickly do so. What you believe is the answer. Well, watch how easy it is. You ready? 3 plus 1 is 4. 2 plus 2 is 4. 1 minus 3 is -2. -1 minus 4 is -5. -10. And 9. That too hard? Does it make you like you're in elementary a little bit? Just a tidbit, right? Not too hard. That's really, some of your problems today is going to be A plus B. Okay? Notice what would be B plus A. Same thing. It would be the same thing. Okay? Notice it is commutative. Write this down, guys. Addition with matrices is commutative. And we should think that it should be. What else is commutative in that we normally know right now besides addition? Multiplication, right? Well, multiplication in matrices is not commutative. Matrix A times B is not the same thing as B times A. Okay. How does that work? I will show you in just a second. Can somebody tell me what is the order of matrix A? The 3 by 2, there's 3 rows, 2 columns. What is the order of matrix B? 3 by 2. Notice they had to be the same order to add them. Could I add A plus C?
No.
Because they are not the same order. I cannot add things unless they are the same order. You might want to write that down. And this is a 2 by 2. Okay. You can go on to the next one. That's our addition. We could do subtraction. Subtraction's not hard, right? We could do that. Do I need to go over that? You guys are okay without doing that, right? Get on to something new, right? But edit, paste. Rewrite that. Okay, I'd like you guys to tell me what A times B is. Give you some. Give it a shot. It's very simple. Guys, does this make you feel like you're going back to elementary seriously? You can do it. I promise. It's very simple. Don't overthink it. I love the cufflinks, by the way. I really want some cufflinks. But I gotta get me some nicer shirts. How was your Rice Krispie treat? Once again, gentlemen, if you are here tomorrow night for the Stuff the Jar night, you get some extra credit. I'd suggest you kind of stay for the whole shindig. Okay. There's activities. Hello. I never made fun of you. Julie, Trevor, or me? If I made fun of you. I did show them, even though it's not how I do it, I showed them your little discernment thing on the outside. This is how I do it. You can choose. Oh, yeah. They didn't understand the water system at all. For real? Okay. No, like, I think some did. Matrices. Or often Nate asked it. Not Abigail. You should care a lot. Tolerant.
I know what you're talking. I just don't know.
She got it.
Yeah. I know it's not fine. They can do it either way. It's just easier to take on the biggest one. You only have to do it once. But they can bring it to the biggest one. There's more opportunity for you.
I totally agree. Anyway, so I gave them half their worksheet and I thought we needed to go over the other half. I sang and a few sang. Can you ever hear the vibrations when I yell? Or feel the vibrations? Yeah, I'm always wondering.
Yeah, he just forgot.
Okay, you guys got it? What do you think? Oh, we've been recorded?
Yeah.
Thanks, guys, for letting me know. So, notice 3 times B would be 3, 6.
They're going to hear you scream on that then.
Negative 9? Huh?
On that. You recorded your screaming.
Negative 12, negative 15, and 18. You guys notice how that is 3B right there?
Yes. Yep.
Notice, and then minus 2A. What's 2A? 6, 4, 2, negative 10, and 6. We continue on. Oops, still too high. Oops, still a little high. So 3 minus 6 is negative 3. 6 minus 4 is 2. Negative 9 minus 2 is negative 11. Negative 12 minus a minus 2 is negative 10. Negative 15 minus a minus 10 makes it a negative 5. 18 minus 6 is 12. That should have been your answer if you did it by yourself. Pretty simple, right, guys? When do I use a machine on multiplication? Let's be honest, when do I use it? There's going to be a time on your calculator, on your test, that you are going to use one on the calculator. There's going to be a time on the test that you're going to do it by hand. So when you practice today, after I show you how to use your machine, what are you going to do? You're going to do it by your hand, and then what? Do it by the machine. You guys understand why you're going to do both? If you don't practice this, guys, you're not going to remember it. Okay? Everybody there with me? Okay, going back, really quick, I'm going to show you. There's my first thing. Notice, guys, watch how this is still this. Because now we know how to multiply, right? Can I multiply a 2 by 2 by a 2 by 1? Is that okay? A 2 by 2 and a 2 by 1, yes, the innermost are the same, right? Notice, watch this. Here we go. What was on my forefinger? 2. What was on my bottom finger? 1. Row by column. So what? 2x plus y. What should it equal? There's your equation. 2x plus y equals 7. Take the second row. 3x minus y should equal 17. It's the same equation, it's just broken out. That's why we can use it. Okay? Notice I forgot something that just came back to me. So, all coming back to me now. You didn't want to sing it?
No, I don't have to. I don't want voicing for you.
What am I doing? Oh, if I gave you A, B, C, D, and I add matrix 1, 2, 3, 4, and I get 9, 10, negative 11, negative 12, somebody tell me a way that I could solve this. What do you mean by subtract? Subtract what? There you go. Because isn't it what we're looking for? Is this matrix here? Well, isn't this matrix A, B, C, D equal to this matrix 9, 10, negative 11, and negative 12? Subtract 1, 2, 3, 4. It's just a matrix equation, just like we had in any other equation. If I had this, guys, x plus 4 equals 7, what would you guys do? You would subtract the 4 over, wouldn't you? It's kind of the same idea, huh? So, therefore, we know that the matrix A, B, C, D equals 9 minus 1, 8, 10 minus 2, 8, negative 11 minus 3, negative 14, negative 12 minus 4, negative 16. Does anybody else have another way that we could have done this? There is another way. We could just simply sit it into simple things. Doesn't A plus 1 equal 9? So what should A equal? 8. Doesn't B plus 2 have to equal 10? So what does B have to equal? Doesn't C plus 3 have to equal negative 11? So what's C? Negative 14. D plus 4 has to equal negative 12. So that's negative 16, right? Another thing, right? Okay, one more thing and then we're done. 2 more things actually. If I said I have matrix 1, 2, 3, 4 plus some matrix here, I don't know what that matrix is, it equals 1, 2, 3, 4. What is that matrix? 0, 0. What does that mean, whoever shouted that? Who shouted that? Can you mind? You didn't do anything wrong. It's right. So far, a little bit. I just wonder what you mean. Was it you? Okay, what did you mean by 0, 0? So what does this matrix have to be for sure, though? When you're adding matrices, they have to have the same order, right? So because that's a 2 by 2, what does this matrix have to be? 2 by 2. So how many zeros do I need to have in there? 1, 2, 3, 4. Because 1 plus 0 is 1. 2 plus 0 is 2. 3 plus 0 is 3, and so forth, right? This guy right here is called our additive identity. Just like when I add 1 to, if I go 1 plus 0, what do I get? I get 1. I get the same answer because what it's doing is it's keeping it the same, correct? With us keeping it the same, okay, that is the additive identity, the 0. For our matrix, it could be 0, 0. Now, what if I gave you a 3 by 2? What would it be? 0, 0, 0, 0, 0, 0, right? And just fill in zeros for the matrix that it needs to be. Does that make sense to everyone? Okay, when I add the opposite of that matrix, so 1, 2, 3, 4, and I add its opposite, which would be -1, -2, -3, and -4. Okay, when I add those together, what would I get? The additive identity. Just like when I had 3 plus a -3, those were opposites, right? The additive opposites. So I would get its identity, which is 0, correct? In our case, the matrix identity. Okay, what if this changed instead of a plus into a time? What is our matrix now? What does it have to be again?
1.
Just ones all everywhere? That's what you think? Okay. 1, 1, 1, 1. That would not be correct. Let's show you why. Because when I multiply, 1 times 2, 1 goes by 1, that's 1. 2 times 1 is 2. That's 3. That's not 1. So this guy right here needs to be a 0, and this guy right here needs to be a 0. Watch with me now. 1 times 2, 1 times 1, 2 times 0. That's 1. 1 times 0 is 0, 2 times 1 is 2. 2. 3 times 1 is 3, 0 times 4. This is called the multiplicative identity. So if you ever want your matrix to be the same, you would use the multiplicative identity. And that's what it is. Now notice, guys, on the additive identity, it could be any order, correct? On the multiplicative identity, it cannot. It has to be a square matrix. What do I mean by a square matrix? 2 by 2, 3 by 3, 4 by 4, and so forth. Okay? That is the only time you can get the exact same matrix as if you have a square matrix. Does that make sense to everyone? Yes.
When it's a 3 by 3, what is that?
If it's a 3 by 3, all you do is go down the diagonals. What I mean by that is it go 1, 0, 0, 1, 0, 1, 0, 0, 0, 1. See how it goes down the diagonal? If it was a 4, you go 1, 0, 0, 0,
Sorry for
0,
the interruption. May I get Shawnee Wilson to the attendance office for a moment, please?
She's not here.
Okay, thank you.
See how it goes down the diagonal? That's what it means. Hey, does everybody understand that? Okay. Should we see one that you might want to use your machine with? Okay, here we go. 1, 2, 3, 4, 5. -6, -7, -8, -9, -10. I'm just doing this, but switching rows, I'm doing negatives. There's our first matrix.
Wow.
Okay, who wants to multiply that guy through? Okay, so let's say we have 1, 2, -3, -4, 5, 6, -7, -8, 9, 10. Can we multiply those two together? We can, can't we? Why? This guy's a 5 by 5. This guy is a 5 by 2. What should it come out to be? It shows us that we are allowed to multiply. It'll come out to be a 5 by 2. Does everybody understand what it should come out to be? This really isn't that hard and we could do it, but it's tedious and long. When it's tedious and long, that's when you use a machine. Let your brain do a lot of the work for you because it makes you smarter. Let's be honest, it does. It makes your brain think, right? Have you ever seen a grandparent that's kind of lazy in their last days and they don't do anything to stimulate their brain, and then a person that does? Do you see their health difference? Has anybody ever seen those? I look at my mother-in-law, my stepmother-in-law, okay? She's 75. She's perfect with her brain, and she moves around awesomely. My grandmother, which was 80, which is 5 years difference, and maybe 5 years difference is huge, it was quite a difference, and they were at the same point 5 years previously. Does that make sense what I'm saying? Just because my mother-in-law, my stepmother-in-law, she does a puzzle every day. Keeps her brain active like a Sudoku or something to challenge herself. That's all I'm saying, guys. Don't let a machine take away your brain power. Sometimes. We could really do this. It would suck, I understand, but we could. Okay? So sometimes, though, think about using your brain. All right. So everybody got your calculator. Okay, we ready? Okay, I think yours will, you have an 82, right? Okay, I think yours will still go. Anybody have an 85, 86? If you have one of those, I will have to play with you in a minute. Okay, here we go. So I turn it on, obviously. On. Okay, and I'm going to hit it. Anyway, so we're here at the main screen. Okay, so what I do is, you guys see matrix above the inverse button? The fourth button down? Is yours right there? Okay, I'm going to have to help you just kind of pay attention, okay? For me, it's right there. Okay. Everybody hit second and then the matrix button. You should be here. Something of that sort. Some of you guys might have some dimensions right by the side of it. Any of you guys have dimensions right by the side of it? It's okay if you do. I'll show you that in a minute. Okay, we want to edit our matrix, meaning we want to come over here and put it in. So I push over a couple times. You have a calculator, right, Parker?
Yeah.
Okay, how big is this matrix? 5, 5, 5. So then I start entering it. So I go 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. Now notice I'm on the second row. You see where I'm at? -6, -7, -8, -9. Notice I'm on the third row. I'm going to finish it out. You guys finish it out as well. Right? You remember doing that? Okay. Everybody good? Okay, so now hit second, quit. Get out of there, go back to your main screen. Were you able to do it? Okay. Now go back into your matrix. I'm going to scoot him over. Go to matrix again. Notice we have our 5 by 5. It says that it's there. I'm going to edit, and I'm going to go down into matrix B now, because I have 2 matrices I want to use, correct? How big is this guy? So I put in a 5 by 2. So I have 1, 2, -3, -4, 5, 6, -7, -8, 9, 10. Oh, you fast little bugger. Get out of it. After you're done, now go back into matrix. Grab matrix A and times. Go back into matrix and grab matrix B. And there it should be. Some of you guys, if you don't get the same number, maybe you missed a minus or something when we were typing it in. You got to be very careful when you're typing it in. How many of you guys got the same answer? Good. Okay, let's go ahead and try b times a. Could we do b times a? A 5 by 2 times a 5 by 5. Let's just show you. So I go second matrix, I want b times matrix A. And it says my dimensions are mismatched. I am not able to multiply those. Does that make sense? Could I do my scalar if I wanted to? Here's how you do your scalar. 3 matrix A times -6 matrix B. I can do scalars as well. Everybody understand? Anybody have a question? Fairly simple? Okay, your homework is 8-2, ladies and gentlemen, 1 through 49. Odd, obviously, and then 61 and 63. Ladies and gentlemen, that is it for